Hello everyone, I am Shivani and welcome to Civil Series. So this video is about the detailed explanation of Test Series 1. This test series is uploaded on our channel on 13 December and the link of this test series is available on community section of this channel. And if you haven't attempted that test up till now, then I upload the link of that test series into the description of this video. And in this video we are going to see the detailed explanation of each and every question in the series or in the test series. There are 25 questions and 20 minutes to attempt for this series, and each and every question is related to BMC syllabus, and this test series is important for sub engineer, and if you want to solve it for the junior engineer, then this will also helps for that junior engineer too. So let's start with the question first. So first question, which of the following estimate mostly resembles a detailed estimate? So here are four options. First one is atom rate estimate. This is one of the type of estimate. Rough estimate, this is not the type of estimate. Then annual maintenance estimate, this is also not the type of estimate. And quantity estimate. Okay, first and last both are the type of estimate, but here the estimate mostly resembles the detail estimate is. Okay, so before discussing that, we discuss the type of estimates here first. So first one is preliminary estimate. Preliminary estimate. So preliminary estimate is that estimate which is calculated approximately. Approximate estimate. And here this preliminary estimate is calculated initially. Then second one is quantity estimate. So quantity estimate is that estimate in this the list of materials to complete the work, the list of material required to complete the work. This is nothing but the quantity estimate. Then next is revised estimate. So revised estimate is that estimate in which the sanctioned project estimate or cost increases and which is more than 5%, then this revised estimate is formed. The next one is fourth is supplementary estimate. So this supplementary estimate is if the work is in progress and some estimate and some material is may be required during the work progress, so that estimate is considered under the supplementary estimate. The next is complete estimate. So in case of complete estimate, each and every material, labor cost, every cost is considered under the complete estimate. All things considered here. Okay, and last one is item rate estimate. Okay, in case of item rate estimate, specification, then design charts, drawing or plans. Okay, each and everything is mentioned in this estimate, and this item rate estimate resembles the detail estimate. Okay, so here the option number 1 is correct, which is item rate estimate. This item rate estimate resembles the detailed estimate. Okay, the next question is Question number 2. What is the minimum distance between the specified position of bridge? What is the minimum distance between the specified position on the bridge? So answer of this question is clearance. Answer of this question is clearance. Clearance is the minimum distance between the specified position on bridge. Okay, so what about this bearing? So bearing is nothing but a provided support provided superstructure for superstructure in abutment and piers. Okay, the next afflux. Afflux is nothing but rise in water level due to obstruction of bridge obstruction of bridge. Then last one is waterways. So waterway is nothing but length of water level between the extreme edges length of, okay, here I correct this, length between extreme edges of water level from bridge is nothing but a water wheel. Okay, so this is about the question number 2. Here clearance is minimum distance between the specified position on bridge. Then next question. Third question. What is the rise in the level of river water due to obstruction of bridge? Okay, rise in the level of river water due to obstruction of bridge is nothing but the afflux. Okay, afflux is the rise in the level of water due to obstruction of bridge. So option third is correct here. So what about the high flood level? So high flood level is the maximum rise in the level of water due to rainfall or runoff. Okay, then next, runoff is the maximum water can absorb by body, okay, or by surface. If that surface reach to its maximum level of absorption and remaining water does not absorb by the surface, or the water which is more than absorption capacity of the surface, is nothing but a runoff. Then next is freeboard. So freeboard is the vertical distance between the water level. Okay, suppose this is the water level, okay, and this is the top of restraint. Okay, and the vertical distance between the water level and the top of restraint is nothing but a freeboard. So this distance is freeboard. This is about the question number 3. Then next question is, then question number 4. On cement concrete roads, the camber is generally provided. Okay, here first we know about the camber. So camber is nothing but a cross slope which is provided on middle of road surface along transverse transverse direction to drain off the water. Okay, for that this camber is used. Okay, and this camber is of 3 type. First, this is straight type camber, second parabolic camber, and third is composite camber. Okay, so these are the 3 types of cambers. Then next, here they ask about the cement concrete road. Okay, based on the material there are four types of the cambers. Okay, material, based on material, cambers are. Next, the high rainfall or the heavy rainfall values are different for the camber, and light rainfall values are different for the camber. Light rainfall. Okay, so here first value is about the cement concrete road. Second is about the thin bituminous. Third is water-bound macadam, WBM, water-bound macadam and gravel. And last, fourth one is earthen roads. Earthen roads. Okay, so here how to remember the values of camber. So first we remember the values in terms of percentage. Okay, here 1.7%, here 2%, next 2%, here 2.5%, then here 2.5%, here 3%, here 3%, and here is 4%. Okay, in terms of percentage. In terms of ratio, here the value is 1 in 60, here 1 in 50, same 1 in 50 here, 1 in 50, 1 in 40, 1 in 40, here 1 in 33, here 1 in 33, and here last one is 1 in 25. Okay, these are the values of camber. Here they ask about the cement concrete road. So the option similar to these option is 1 in 48 to 1 in 60. Okay, this is nearly equal. So option number third is correct here. Next question. The next question, question number 5. What will be the theoretical maximum capacity to nearest 10 units for a single lane of highway, given that the speed of the traffic stream is 40 kmph, 40 kilometers per hour, kmph. Okay, so here to calculate this maximum capacity, the formula is C is equals to 1000 V by S. Okay, by S. This C is nothing but a capacity in vehicle per hour. Okay, then V is speed in kmph, and S is nothing but a minimum clear distance between two vehicles, S is equals to 0.2 into V plus 6. S is equals to 0.7 V plus 6. Okay, this is the value for the C, values for the S. Okay, then put the given values into this formula. So C is equals to, here this C is equals to 1000 into V is 40 divided by, here this 40 is given in the kilometer per hour, kmph. So this formula is for kmph and this formula is for meter per second. Okay, so here 0.2 into V plus 6. Put the values into this formula. So 1000 into 40 divided by 0.2 into 40 plus 6. So after calculation, you get the C value, capacity value as 2860 vehicle per hour. Okay, so this is the answer for this question. So here option number 2 is correct. The next question. Question number 6. As per IRC, the maximum value of super elevation in hilly roads not bound by snow should not be more than. Okay, here is one chart for the super elevations value. For super elevation value, so super elevation for, and here the maximum values of super elevation as per IRC. Okay, in that different conditions are there. First condition is super elevation for plain and rolling terrain. Plain and rolling terrain. Second condition is bound by snow. Bound by snow. And third one is not bound by snow. Okay, these are the three conditions here. Then the value for the first condition, plain and rolling terrain, is 7%, means 1 in 15. 1 in 15. Then second is 7%, 1 in 15. And last one is 10%. Okay, 10% is value for not bound by snow. So here the option number second, here the option number not second, option number third is 10%. So option number third is correct here. The next question is question number 7 is the soil which can store water and allow a small quantity to flow. First, it store water and allow a small quantity to flow over it over a long period is called as. Okay, here there are four terms. We'll discuss the four terms one by one. In that, first one is aquitard. Second is aquifer. Third term is aquiclude. And fourth one is aquifuse. Okay, remember the order. First aquitard, aquifer, aquiclude, aquifuse. Remember it as TFCF. Okay, here TFCF. Okay, last is fuse. Okay, remember last is fuse, TFCF. Here the examples for this is silty, second dash, third is clay, and fourth one is rock. Okay, these are the examples. Next, how to identify which is aquifer, aquitard, aquiclude, and aquifuse. For that, first, this structure is porous. This is porous and non-porous. Okay, then porous and less permeable. Then this is porous and permeable. Third one is porous and impermeable. And last one is non-porous and non-permeable. Okay, this is about the aquitard, aquifer, aquiclude, and aquifuse. Here the soil which can store water. First, it store water and allow a small quantity to flow over it over a long period of time. Permeable means it releases water fastly. Impermeable means not releases water. Non-permeable, it also not allow the water to flow through it. Then this condition is suitable here. Less permeable means it require a long time to flow. Okay, so the option number second is correct here, which is aquitard. The next question is, then question number 8, statements are given. First statement is Terzaghis bearing capacity theory assumes strip foundation in the analysis. Yes, they assume a strip foundation for the analysis. Then second, Terzaghi theory does not consider the development of shear resistance. Here does not consider the development of shear resistance in the soil mass which is above the foundation level. Both the statements are correct. Here they consider a strip foundation, and next the shear strength is not considered in the soil mass which is above the foundation level. Both the statements are correct here. So option number first is correct. The next question. Question number 9 is a column with maximum equivalent length has. Okay. First of all, we'll see the chart of equivalent length. So equivalent length here, equivalent length for conditions, for different conditions. Okay. First condition is when both the ends are hinged. When both the ends are hinged, then the equivalent length is L. Second, if both the ends are fixed, then the equivalent length is L by 2. L by 2. The next condition is, third one is when one end is fixed and another end is hinged, then equivalent length is L by root 2. The next, fourth one is if one end is fixed and another one is free, then the equivalent length is 2L. So by seeing this chart, they ask about the maximum equivalent length. So here in this chart, the maximum equivalent length is 2L, and 2L is maximum equivalent length for the condition that one end is fixed and another end is free. So in the option number 4, one end is fixed and other end is free. Okay, so here the option number 4 is correct. If both ends are hinged, the equivalent length is L. If both ends are fixed, equivalent length is L by 2. If one end is fixed and other end is hinged, equivalent length is L by root 2. When one end is fixed and other end is free, equivalent length is 2L. The next question is question number 10. The deflection at center of simply supported beam of span L which is subjected to concentrated load W at its midspan. Okay, so there are different conditions of the beams with different loadings for the slope and deflection. So first we'll see the conditions. So in that, first condition is the type of beam or the type of condition or beam. Okay, first is this is cantilever beam with a movement at its end. Then second, cantilever beam with point load. Third one is cantilever beam with UDL. Then fourth one is cantilever beam with uniformly distributed load UVL. Then next is simply supported beam with point load at its center. This is L by 2, L by 2. This is W. Then simply supported beam with UDL. Okay, these are the different conditions. So movement for these conditions are, okay, let me draw first. So here the movement for the first condition is if this is M, movement is equals to M. This is W, this is L, W into L. Here L is here, WL square by 2. For this, WL square by 6, WL by 4 and WL square by 8. Okay, these are the movements for these different loading conditions for different beams. Then next is slope. So first of all, the slope formula, to find out the slope value, there are simple calculations. Okay, by these simple calculations, you remember all the values of the different conditions. So first is ml by EI. Second is ml by 2 EI. Third one is ml by 3 EI. Fourth one is ml by 6 EI. Sorry, ml by 4 EI. Okay. Then here reverse the value ml by 4 EI and ml by 3 EI. This is about the slope. Okay. So first we see the short forms or the short terms to derive the formula. Then for deflection the terms are here L by 2, 2L by 3, 3L by 4, 4L by 5, then L by 3, 5L by 16. Okay, so these are the small values to derive the formula. Here how to calculate the value? First I solve for the first beam, cantilever beam with the movement. Okay, to find out the slope value, just put the value or replace the value of m with the movement. So here if I replace this m with this m, the value is ml by ei. ml by ei. Okay, and multiply this slope with L by 2. ml by ei. So this value is nothing but a deflection, which is ml square divided by 2ei. Okay, this is how you calculate the remaining values. But here they ask for simply supported beam with point load. So for this we calculate here. So replace this m with wl by 4. So the value is wl by 4 into L divided by 4ei. Okay, so this is what the calculation. If we done this calculation, then we get the WL square divided by 16 EI as a slope. If we put this value into a multiplication for this L by 3, then WL square divided by 16 EI equals to WL cube divided by 48 EI. Okay, here this value is in option number 1. So option number 1 is correct for this question. The next is question number 11. A roof with slope in all four directions. Slope is in all four directions with break in each slope. With break in each slope is known as, okay, if slope is present on each four directions and with a break, then that slope is nothing but a mansard. That slope is nothing but a mansard. So here option number first is correct. Then what about the remaining roof? So deck roof is that roof which is provided with a four direction slope. But here the top part is flat. And the remaining part is with a four direction slope. The next is mat roof. Mat roof is nothing but a flat roof. Okay, slope is not present here. Mansard roof is also known as French roof. The next question is question number 12. Which is the code used for the classification of timber for seasoning purpose? Okay, here the first code is used for the identification of commercial timber. And the last one is for classification of commercial timber and zonal distribution. Okay, then this second one is used for the method of testing small specimens of timber. And this third one is used for the classification of the timber for seasoning purpose. So here option number third is correct for the question number 12. The next question is question number 13. Which of the following statement is not true for the movement distribution method? In that first statement is the movement distribution method was first introduced by Hardy Cross in 1932. So first statement is correct. Second statement is the movement distribution is suitable for the analysis of specific types of intermediate beams only and not. So here after this not, here the statement is for frame rigid frame, and the state after this cy the statement is cycles each converging towards the final result. Okay, so here we read it again. The second statement, the movement distribution is suitable for the analysis of specific type of intermediate only beams only and not for rigid frames. Okay, so here the statement second is not correct, because the analysis of specific types of intermediate, it is suitable for all beams and frame. Okay, suitable for all beams and frame. So this is the correct option, correct option, but for this question this is not true. Here we read the remaining options. It is also called as the relaxation method, and it consists of successive approximation using the series of cycles, each converging towards the final result. So this statement is true. The next, the movement distribution is an iterative method for solving an indeterminate structure. Yes, this option is also correct, true statement. But in the question they ask that which statement is not true. So here the option number second, option number 2 is not true statement for the movement distribution method. So the correct option for the question number 13 is option number 2. The next question is then question number 14. An RCC column is regarded as long column if the ratio of its unsupported length between its least lateral dimension is more than in case of unsupported length, the least lateral dimensions are depend upon the slenderness ratio, and for the long column the slenderness ratio is 60. Okay, here the unsupported length is used for the long and short column. So for question number 14, option number second is correct. The next question. Then question number 15. In mixed design for M25 concrete, the assumed standard deviation for estimation of target mean strength of concrete mix as recommended by IS 456-2000 in Newton per mm square. Okay, here is a chart for the assumed value of standard deviation for the initial calculation as per the IS 456-2000. Okay, here in the question they asked about the M25 grade. So in this chart for the M25, the standard deviation is 4 Newton per mm square. So option number 2 is correct here. And these are the remaining values for M10, M15, 20 up to M55. The next question is question number 16. The maximum value of effective slenderness ratio as per IS 800 for tension member in which the reversal of direct stresses occurs due to loads other than wind and seismic load. So here in this chart, the tension member in which the reversal of direct stresses due to the loads other than wind and seismic, the slenderness ratio is 180. Here, a members normally acting as a tie in a roof trusses or in a bracing, and that are subjected to reversal of the action of wind or earthquake load. Here the action of wind and earthquake load, then the slenderness ratio is 350, and if the members are always under tension, then the slenderness ratio is 400. So here in the question they ask about the loads other than wind or seismic forces. Then here the option number D is correct, which is 180. The next question is, then question number 17, what is the carbon content percentage in mild steel? So mild steel is considered under the low carbon content steel. Low carbon content steel. So the content for the mild steel is 0.15 to 0.3%. Here the last option is correct for the carbon content of mild steel. The next question, question number 18. In critical path method of construction planning, free float can be. Okay, here free float can be. First option is greater than total float. Free float is not greater than the total float, means free float is not greater than the total float. Then second is greater than independent float. Okay, this second option is correct. Then equal to total float, this is also correct. And then last option, less than the independent float. So the free float is not less than the independent float. Free float is more than the independent float. So here second and third option is correct. So option number 2 is correct, that only 2 and 3 are correct. The next is question number 19. In a bar chart, the vertical axis represent. So for bar chart, this is the graph. On x-axis represent time and y-axis represent activities. Okay, here two important sentences. First sentence is activities shown on, and second is activities shown by. Activities shown by. So for first, activities shown on vertical axis or y-axis, and second shown by horizontal line and bar. Okay, then in the question, the bar chart, in a bar chart the vertical axis represents the various activities of project. So here option number 4 is correct. Then next is question number 20. The expected outturn in cubic meter of reinforced brickwork per mason per day is. This is the chart for expected outturn. First, cement concrete outturn is 5. For lime concrete in foundation 8.5. For reinforced brickwork 1. For RCC work 3. Brickwork in lime or cement mortar in foundation and plinth is 1.25. So here option first is correct. The expected outturn for the reinforced brickwork is 1. Next question. Question number 21. A line joining some fixed points on main survey line is called as. A line joining some fixed points on main survey line is tie line. Okay, so option second is correct, and the explanation of this check line, tie line, chain line and base line is explained in the short notes video of surveying in detail. Okay, the next question is question number 22. What must be the radius of circular curve for railway of chord length 30 meter where the degree of curvature is 2 degree? There are two formulas for different two conditions. First, when chain length is 30 meter, and second 20 meter. If chain length is 20 meter, the formula for the degree of curvature is D is equals to 1719 by R, and if that chain length is 20 meter, then degree of curvature is 1146 by R. Okay, here the chord length is 30 meter. So this formula is used to calculate the radius of curvature or radius of circular curve. So here the value of d is 2 degree. So put that value into the formula. R is equals to 1719 divided by d. 1719 divided by 2 degree, and that R is equals to 860 meter. So here option number third is correct, which is 860 meter. The next is question number 23. Zero hardness of water is achieved by, these are the three methods for determining the hardness. First one is lime soda softening, second is zeolite softening, and third is ion exchange process. So for zero hardness of water is determined by the ion exchange process. So here option number 3 is correct, and this is the difference between the three methods of hardness. Then next is question number 24. Which type of odor characteristics is not used for classifying odor of a given water sample as per IS 3025 part 5 19832? Okay, in case of odor characteristics, as per this IS code, there are four characteristics. In that, first one is sweetness, degree of sweetness, then degree of punginess, and third is degree of smokiness, and last one is degree of rottenness. Degree of rottenness. So these are the four degree or four odor characteristics, but the degree of turbidity is not the characteristic. So here they ask about not used. So option number first is correct here. The next, then last question number 25. Degree of kinematic indeterminacy of given beam is, okay, to find out the degree of kinematic indeterminacy, dk is equals to 3j minus re. So here joints are, this is first joint, second joint, 3 into 2 minus, reactions are, here for fixed beam 3 reactions are there, and for roller 1. So Re is equals to 4, 6 minus 4 equals to 2. So this 2 is the dk for this given beam. And there is one another method to find out the degree of kinematic indeterminacy, which is, okay, so here the fixed beam is given. If fixed beam is there, then the degree of freedom for fixed beam is 0, and the degree of freedom for the roller support is 2. By adding the degree of freedom, summation of degree of freedom is equals to dk. So here 0 plus 2 equals to 2. So this is how you calculate the kinematic indeterminacy, and the degree of freedom for the rigid frame is 3, and for the hinge support is 1. Okay, so this is all about the test series and the questions, and thank you for watching.